A farmer claims that the mean weight of the melons grown in the farm is at least 12. Okay, so this is the at least 12 lah. So meaning, right, some of us will think that H naught is at least 12 kg like that. Okay, like that, at least 12. Is this wrong? No, it's not. Okay, it's just that it's not in your syllabus. Don't see in your syllabus. But it's not wrong to write like that. Essentially, you just assume that this is whatever he claims is all these values here are he claims to be true, right? So you take the minimum lah. So the H naught can change to mu equals to 1.2 kg. Understand? Take the lower bound. You don't need to test for 1.3 ma. If 1.2 is correct already, then you don't need to test for 1.3 and so on ma. So that's the whole idea there. Okay. So a random sample of 10 melons is chosen and the weight is recorded. So these are the results. So these are sample results. Okay. Sample. Just be very mindful of what data you're receiving. Okay. Assuming that the weight of a randomly chosen melon follows a normal distribution. So meaning the population is already known to be normal. Alright, it's known to be normal. Carry out appropriate tests to further claim at 10% levels anyway. Okay, great. So I'm gonna let usual. I'm gonna let mass mass of a melon. Of a melon. Okay. Okay. Don't write the mean. So this case here, what we need to do is actually just assume so H naught, right? Mu. Like I say, right, you take the lower bound, which is 1.2 kg. Then what mu1 it will be mu. Okay, I do not know what is the left tail or right tail, right? But to claim against the farmer's test, it should be less than 1.2. But let's say if you don't know, you can actually just deduce. Let me show you how. So this is alpha percentage, as far as you know, is 10%. So now our whole goal is find out what is 10. There are 10, n is 10. We need to find what is x and what is our s, our sample mean. S. Okay. So what do? You just go to your calculator, key in the data here. Okay, your cashier can do it also. So but never mind, we just use calculator here. Key in the data, go to the header row, clear everything. Just key this 1.037. So 1.037, key all this in. 1.037. I'll just key it in. So once this is done, create stats, calculate one variable stats, and then clear the frequency list, please. Clear it, because everything just happens. There's no frequency list. You only have each data point, 10 data points here. So just calculate. Okay. So sometimes the question will give you like frequency list lah. So you just key in the calculator. It's the same thing. So this is what you get. Copy this down. These are where you need to make sure you know the symbol. So if you are using unbiased estimate of population standard deviation, so this would be 0.179503296. Your x bar here would be 1.1021. Okay, this is the sample standard deviation. This is the unbiased estimate. Okay, so just use the S there. Great. Once done, okay, so now we can test lor. Everything is nicely done, right? So under H naught, so x bar normally distributed of 1.2. Oh, so this one here, you see this one, this mean here is 1.1 kg. This is 1.1 kg, so it has to be the left tail. Okay, because it's less than 1.2, it cannot be more than that, because if it's more than that, uh, it doesn't make sense to test it. You want to test, you test on the left. Okay, in this case here. Now I know some teachers will say this is not the correct way to do it. But heck, you're having tuition. You want to know how to answer the question. Uh, it only makes sense when the yeah, just know which tail to choose based on the X bar lah. But it doesn't always work, which is true lah. That's why sometimes we don't encourage you to do that. But if you're desperate, this is 92% of the time it will work. So this is 1.2. Then you have S square here over 10. Okay. So test statistic. Test. Okay. All right. So now we can just use our favorite GC lah. It will be let's just use GC. From GC, P value is what? Just key in P value. Yeah, mu naught is 0.2. Sigma is 1, 0.1795. 0.329. X bar is what you test out with 1.0. Oh, it's keyed in. Oh, save it for you. Wow, amazing. Oh, I didn't know that. Okay. Okay, calculate. Okay, this is the value here. Be which is actually less than 10%.